Assalamu alaikum. Welcome to Fahad's tutorial once again, and this class is about the molar volume of gas. So I hope you saw my first video that I have uploaded based on the chapter or concept of mole and regarding the topics that we need to consider, and I explained about a little bit about mole. And in this video I shall be explaining about the molar volume of gas. So when we think about these words, we need to think two keywords, that it is gas and we are thinking about the molar volume. So the definitions of molar volume is that in STP, and I hope you know that what is STP, which is actually the standard temperature and pressure. So what is actually standard temperature and pressure? Till 1982, it is said that STP means the temperature is 0 degrees Celsius or 273.15 Kelvin or 32 degree Fahrenheit. So this temperature is called standard temperature, and the pressure is 1 atmospheric pressure, which is 101,325 Pascal. So these temperature and Pascal, if it is fixed, so in this temperature and in these pascals, the volume that 1 mole of gaseous substance occupies, so that is called the molar volume. So as it is a gaseous substance and the amount of space or amount of volume that it occupies in STP, any gas, that is called the molar volume, and this molar volume is fixed. Usually in STP the molar volume is actually 22.4 liter. So we need to think about it. This 22.4 liter is our ideal value of this class. So we need to think, we need to memorize that the molar volume of any gas in STP, this is very important, it must be announced, it must be mentioned that in STP the molar volume of any gaseous substance is 22.4 liter. Now we think that what is actually the STP. So we know that STP is standard temperature and pressure. So as we know that this is standard temperature and pressure, the standard temperature is 0 degrees Celsius or 273.15 Kelvin or 32 degree Fahrenheit. This is all same, that means 0 degrees Celsius is actually Kelvin, is actually Fahrenheit, and you know that from your physics chapter 6 when you studied about heat and temperature. On that chapter you studied about the different scale of temperature, and remember that you studied about Celsius, Kelvin and Fahrenheit. So it's all about same, and the pressure is 1 atmosphere, which is called 1 atm, and this is about 101.325 kilopascal, or is actually 101,325 Pascal. So if these conditions applied in STP, I mean in standard temperature and in standard pressure, the gas, I mean the volume that contained by 1 is mole gas, that is called the molar volume. Now we think about some gases, like the gaseous substance, like think about carbon dioxide, think about sulfur dioxide, think about ammonia, even methane, which is very common gases. So think about these 4 gases, we'll talk about it, that carbon dioxide, sulfur dioxide, methane or ammonia. So these amount of gas, and now we need to find out the mole of this gas. Suppose carbon dioxide. So can you remember the molecular mass of carbon dioxide is 12, carbon 12, oxygen is 16 times 2, which is together 44. So 44 is the molecular mass of carbon dioxide. Now we think about methane. And I think you know this is 12 plus 4, this would be 16. What about sulfur dioxide? Sulfur is 32, oxygen is 16 times 2, it's together 32 plus 32 is 64. And what about ammonia? So if it is ammonia, it's 14 plus 3, which is 17. I just keep it as an example that I will do it about mathematical problems, that carbon dioxide molecular mass is 44, methane is 16, sulfur dioxide is 64, and ammonia is 17. And students, I'm just giving you something like, if you face any trouble to find out these, then understanding this chapter would be so much tough for you. So before going to understand the topic, this chapter, actually the concept of mole, and something's very interesting coming up, you need to find it out. You need to find it out very frequently, and you need to remember the atomic mass as much as possible. So I think this would be easier for you. You need to remember the molecular mass of carbon dioxide: 44, 16, 64 and 17. Most common gases. Now think about these. In gases, when we will find out the mole of gas, we need to think about three things. Either it is volume, either it is number of molecules, and the mass of the gas. So you must think about three things when finding the volume, molar volume of gas, in case of number of atoms, number of molecules, mass, and volume, mass, and molecular number. How to find it out? If you say that the mole of a gas, that is mass upon mass, I'm coming up with this. This W is the mass in gram. What is mass in gram? Suppose if the question is that 5 gram carbon dioxide. Suppose the question is what is the mole in 5 gram carbon dioxide. So you know that carbon dioxide is a gaseous substance, and in STP the molar volume of carbon dioxide is 22.4 liter, which is fixed. Now the question is, what is the mole of 5 gram carbon dioxide? If carbon dioxide are there, now you think that W is 5 gram carbon dioxide. Now you think the molecular mass of carbon dioxide is 44. Now you think 44. If the question is what is the mole of 5 gram sulfur dioxide, then the mole number of sulfur dioxide would be 5. As you know that sulfur dioxide is 64, so 5 upon 64. If the question is what is the mole number of 5 gram ammonia, then it would be 17 upon 17. Now you see, if every value would be less than 1, and that is the mole of carbon dioxide, the mole of sulfur dioxide, the mole of ammonia. So whenever you think about the mass, so mass upon molecular mass, that is the mole. So when we understand the mole number, you think, when I need to determine the mole number, then we need to think that mass upon mass, volume upon volume, number upon number. How? That if you think about the mole about number, so now you need to think the number upon the mole number, which is the Avogadro number, that is 6.02 times 10 to the power 23. Now you think the mole number of any gaseous substance in number of molecule. Suppose the question is that what is the mole of carbon dioxide if there are 2.62 times 10 to the power 22 molecule are present. So if this is the question, then if, like I say, 2.62 times 10 to the power 22 molecule, so you say that 2.62 times 10 to the power 22, that amount of molecule is how much mole of carbon dioxide, then that is upon 6.02 or 10 to the power 23. So if you divide the number, you will have the mole of carbon dioxide in this amount of molecule. So I think you understand that number upon number, mass upon mass. And again, similarly, if you again want to find out the mole number of any gaseous substance, then volume upon volume. Suppose what? Volume upon volume. So this is 22.4 liter. Now my question is, if the question is what is the mole of 500 liter sulfur dioxide, or even the question what is the mole of 10 liter ammonia, if this is the question, then 10 liter ammonia, so it would be like 10 upon 22.4. If the question is what is the mole of carbon dioxide when it is like 500 liter, then this is 500 liter upon 22.4 liter. So using your calculator, you can calculate these things very easily, but the thing is, do you understand the concept? Like determining the mole number of gas, what we are doing, we are trying to figure it out in a similar category of quantity, like mass upon mass, number upon number, volume upon volume. So when you're trying to determine the number of moles of any gas, then these things should not be missed by you. So I hope you understand. W, that means mass in gram. M, that means molecular mass of that gas. This N is the number of molecules, so number of molecules actually, because gas, nitrogen gas, carbon dioxide, which is very common. I just took some common gases so that you can understand the concept. As I'm in very primary level discussions, I'm going through based on your book what is in the academic syllabus. You feel like it's very easy, but those students are starting their study and thinking from the beginning. For them, I'm just talking about. So I hope you understand. Now let's do some mathematical problem. I'm just removing it. Before going to remove it, trying to say that the STP, and you must remember what is the molar volume of gas. So you must say that in STP, standard temperature and pressure, the volume that 1 mole of gaseous substance occupies. Now you think about these alphabets, that N, the mole number, W is mass in gram, V is volume in liter, capital N means the number of molecule, though I just put it hash there, but capital M is the molecular mass. So you think about how to determine the molecular mass and how to use it to find it out, the mole number of a gas. So I hope you understand this level. So I am removing it. Okay. Now we will think about something special. That is that. So if I am taking some mathematical problems from your books so that it would be easier for me to figure it out. Suppose the question is how many molecules are there in 5 liter carbon dioxide gas. So if this is the question, that how many molecules are present in 5 liter carbon dioxide gas, now think about it. So the question is, suppose 5 liter ammonia, suppose. So 5 liter ammonia, the number of molecule was asked. So how many molecules are present in 5 liter ammonia? So now you think in STP, so in STP, the molar volume of ammonia is 22.4 liter. You know it? So as it is molar volume, that means it contains 1 mole amount of gas, and as this is the molar volume, so it will contain 6.02 times 10 to the power 23 molecule. Okay? So now you think, if 22.4 liter contains this amount of molecule, so how many molecules will be contained by 5 liter ammonia? So you think about as it is this. So 1 liter is 6.02 times 10 to the power 23 upon 22.4. So 5 liter 6.02 times 10 to the power 23 times 5 by 22.4 liter, and the answer is, I need to use my calculator, 6.02 times 10 to the power 23 times 5 divided by 22.4 is 1.34, 10 to the power 23. So 1.34 10 to the power 23 molecules are present in 5 liter ammonia. Now you think, in determining the molecules number when liter will be present, we not need to find out the molecular mass here. We are just determining the liters and the number of molecules. So we need to find out the molecular mass of the gas. But in case of finding mole numbers, and if the molecules number are present, then we need to determine 6.02 times 10 to the power 23. So I hope you understand. Okay, and then if the next question is that what is the volume of 10 mole carbon dioxide gas at standard temperature and pressure? So if this is the question, what is the volume of 10 mole carbon dioxide? Now you think, if the question is what is the volume of 10 liter, what is the volume of 10 mole carbon dioxide? So the question is, this is given 10 mole carbon dioxide and 10 mole carbon dioxide and the amount of liter. So 10 mole carbon dioxide in 1 liter. How much the liters will be present there? So if 10 mole carbon dioxide, we know that in 1 mole, which is actually 22.4 liters. So if I say that 1 mole is 22.4 liter, then what about the 10 moles? I just need to multiply by 10. And if I multiply by 10, then it will be 224 liter. So 10 mole carbon dioxide is actually 224 liter carbon dioxide. But if the question is that how many atoms are present in 5 liter sulfur dioxide gas? Now something interesting up there. So if the question is that how many atoms are present in, suppose, 50 liter ammonia at STP. Okay, so if this is the questions, how many atoms are present in 50 liter ammonia at STP? Now you think, in 1 molecule of ammonia, you think there are 1 nitrogen and 3 hydrogen. That means in 1 molecule of ammonia there are 4 atoms. Now you think that how many atoms are present in 50 liter ammonia? So we know that the molar volume of any gas like ammonia in STP is 22.4 liter. We know it. And in these 22.4 liter, how many molecules will be present? 6.02. So as 22.4 liter contains 6.02 times 10 to the power 23 molecules. Now you think that 50 liter. So 50 liter will contain 6.02 times 10 to the power 23 times 50 upon 22.4 molecules. Now we will find out the molecule number. So 6.02 10 to the power 23 times 50 divided by 22.4, which is 1.34 10 to the power 24. 1.34 10 to the power 24 number of molecule. But the question was, how many atoms? This is the number of molecule, but we need to find out the number of atoms. We know that in one atom of ammonia there are 4 atoms, one molecule of ammonia. Suppose in case of H2SO4, think about that. In one molecule of H2SO4, how many atoms are there? There are 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atom. So you think it has 7 atoms in one molecule. But in case of ammonia, there are 4 atoms. So as we find out that in 50 liter gases, it has that amount of molecule. So now we just need to multiply by 4 to find out the atoms. So if I multiply by 4, then it is 5.375 times 10 to the power 24 atoms number. And this is the answer. So nothing is critical. I'm just writing it at my own hand so that you can practice at your home, and you definitely will feel the confidence regarding the finding this molar volume of a gas. You need to remember one thing, that in STP, it should be in STP. So STP means standard temperature and pressure, and there are another thing which is SATP, which is standard atmospheric temperature and pressure. I'll definitely discuss it on later on, but here the molar volume is 22.4 liter. Any gas, the volume of 1 mole gas is 22.4 liter in STP. So whenever you think that 22.4 liter and the Avogadro number and the mole, then doing these mathematical problems in this chapter would be much more fun to you, and you will definitely feel better when you do these mathematical problems, I promise. So this is a very short video about the molar volume of mass, and I'm coming up with the next video regarding the molar solutions and empirical formula and finding the way of molecular formula. So see you on the next class. Stay well, stay blessed. Bye.